bend until it breaks. It still bends. No. With wood, you're not so much going to get this. You might a little bit. But you definitely will with metals. And this is kind of an important diagram for you guys to understand. It takes a little bit of time to kind of get the deep concept here, but something called strain. When we think about strain, strain is the type of deformation that takes place due to the stress. So when we think about strain, it's really what's happening to this piece. So as we're talking about this, I don't want you to think so much about rock, but I want you to think about metals. Okay, I want you to think about just an average piece of metal. Doesn't matter what you think of, just think about the metal. And I want us to look at this diagram, and don't worry about too much about the questions right now. We'll come back to those. Well, look at this diagram. We have the stress increasing. So as we increase our stress, we increase our strain. And we have two types of deformation. We have elastic and ductile. What does elastic mean? Stretches. And then what happens when you let go of that stress?
It goes back.
Goes back to normal. Okay. What about ductile? It stretches and it stays that way. Okay, so elastic means once that stress is done or after it's been applied, that object will snap right back into place. With ductile, we've stretched it, or basically applied so much stress that it no longer will go back to its original position. That's what the two mean. So elastic, it'll go back to its original shape. Ductile, it's permanently deformed. It's never going back. So, what's happening here at the X? That's the breaking point. Good. Okay, that's the place at which our substance completely breaks. All right, you can only bend it so far before it finally gives way. So think about a piece of metal. We start bending. Remember the piece of tin I had at the beginning of the semester? Where you could bend it, and you can actually hear the crystalline structures within the metal cracking. You guys remember that? It's a big wand of tin, and I bend it. And then if you just apply just a little bit of stress, the tin would realign itself, right? But if you applied too much stress, it became a bent piece of metal, permanently bent. Okay? That's the ductile. When it bends permanently, that's the ductile deformation. And some of you guys kept bending it back and forth, and what happened? It broke. Okay? That's the X. Okay? That's where we've applied so much stress that it basically broke. And so when we think about rocks, rocks will do the same thing. Okay? Perfect example of this is when we look in our region today, take the glaciers that sat over on top of our entire region. Think about a mile-high sheet of ice. Weighs just a little bit, right? Solid ice, sitting on top of the land. So what is that going to do to the land?
Push it down.
Push it down. Okay, that's a type of deformation. And then, so that downward force is a type of strain. But as the glaciers melted, what happened to that force then? The force went away, so what did the land start to do? To rise back up. Okay, that's what we call isostasy. Okay, you guys want to write that one out? It's not anything you need to know basically for this lesson, but it's kind of an important term to know in general. Isostasy. And it's basically where we have the land rising back up to its original position prior to the glaciers. Okay, so it was depressed, now it's rising back up. Excuse me. So, same thing happening here with our rocks. That's the elastic deformation when it goes back to normal. But in some regions, for example, in the mountains, the rocks become permanently bent and folded. So a lot of times, there's a few places in the world where you can actually see this, and they're really neat. You get these whole wavy layers in the mountain process. So now within the tiny rocks, when we saw a little bit of foliation with some of our metamorphic rocks, this is going to be on a giant scale. We actually see it bending and twisting through the mountain sides. Okay, that's an example of ductile deformation. And then eventually, the rocks do break.